In this illustration, we intend to simulate Double-HSS link under the cyclic loading in the Abaqus software. In the right picture, you can observe the model having been made in the laboratory, and in the left picture, the sample simulated in the Abaqus software can be clearly observed. As you observe in this picture, the model includes two HSS, gusset plate, weld, and end plate. In this problem, a cyclic loading is applied to the model, and then its hysteresis diagram will be drawn. In this picture, the hysteresis diagram obtained from the Abaqus software has been compared with the laboratory results. Actually, we intend to simulate this article in the Abaqus software. The article is entitled Seismic Behavior of Double-HSS Links for Eccentrically Braced Frames. I will enter the Abaqus software for simulation. I will click on Create Part. I intend to create geometric shape of HSS. I will select the modeling space as 3D. From here, deformable, then select solid and extrusion. Enter approximate size equal to 1000 and continue. Here you can observe the specifications of HSS. I will draw a rectangle and enter its length equal to 127 millimeters. Its width equal to 50.8. In the next step, I will click on Offset Curves. Select the whole of the rectangle. Done. The thickness is equal to 6.4 millimeters. And OK. Done. The length of HSS is the sum of 235 plus 558.8 plus 235. The length of HSS itself is equal to 1028.8 millimeters. Click on Create Boundary Condition. Then select Displacement Rotation and continue. Here I will select this surface. Done. And close boundary conditions of displacement for them. In the next step, we intend to draw the hysteresis diagram of the model. Actually, we intend to draw this diagram in the Abaqus software. The horizontal axis is total link rotation angle, and vertical axis is shear force. I will click on Create XY Data, select ODB Field Output, Continue. Here select Unique Nodal, then select RF2, and after that U2. Here I will select Set 2, that is related to the place of cyclic loading, and click on Save. I will click on Create XY Data, select Operate on XY Data, and Continue. Here we should add all reaction forces up together. Here we should divide the quantities of displacement by the link length. Here link length is equal to 558.8 millimeters. In the next step, I will click on Combine. Then select Rotation. And after that, Force, and click on Save As. Here you observe the hysteresis diagram having been drawn in the Abaqus software. I will transfer that to the Excel software. The first column is rotation, the unit of which is radian. The second column is force, the unit of which is Newton. Here, the diagram having been drawn with green color is the one obtained from the Abaqus software, As you observe, the results obtained from the Abaqus software are similar to the laboratory results. In fact, the results obtained from the Abaqus software here are similar to those mentioned in the article.